Question 8. We have a spherical meteorite in outer space. Here it is. Spherical meteorite. And it has a radius of 10 meters. It's quite small. A particle of mass m is projected vertically from its surface with initial velocity 20, u is equal to 20, and it's attracted back towards the center of the Earth. So we're going to need to add that 10 on at some point. By a force, so we're given the force here, force is equal to, and it has a magnitude of 5000 m over x squared, 5000 m over x squared, and x is a distance from the center of the meteorite. So this, from here, we're going to be looking at x going up this way. So the force coming back down is in terms of x. Find the velocity of particle when it's 30/7 meters above the meteorite. So what we know is, we know this force, it's going to slow it down, of minus 5000 m over x squared is equal to ma. And the mass, we need to think about the mass, just m times a. So dividing by m and allowing a to be equal to, we're dealing with x here, so it's normally v dv ds. So we're dealing with v dv dx in this case with displacement. So minus 5000 x to the minus 2 might be the easiest way to write it. We're going to integrate it. Minus 5000 x to the minus 2 is equal to v dv dx. So minus 5000 x to the minus 2 dx is equal to v dv. And we're going to integrate these. And this is where the radius comes in. So we have initial velocity of 20. And we have, it's going to reach a height of 30/7. So let's find the velocity. And then for x, it's starting above 10, above where in terms of x is. So it starts at 10. And then it's going to go x. So we integrate these, we're going to get minus 5000 x to the minus 1 over minus 1 between x and 10 equal to v squared over 2 between v and 20. So we need to get velocity in terms of distance, so let's simplify it down. We're going to get 5000 x to the minus 1, so 5000 over x between x and 10 is going to be equal to v squared over 2 minus 20 squared, 400 over 2 will be 200. So on this side we're going to get 5000 over x minus 5000 over 10 is 500 equals v squared over 2 minus 200. So we want v, so I'll bring the 200 across, so we're going to get 5000 over x minus 300 equals v squared over 2. Multiplying by 2, I'm going to get 10,000 over x minus 600 is equal to v squared. So v is equal to the square root of 10,000 over x minus 600. And we were asked to find the velocity of the particle when it's 30/7 meters above the meteorite's surface. So the 30/7 above the surface. We'd have to add 10, which is 70/7. So we'd have to put in 100/7. So the velocity is equal to the square root of 10,000 divided by 100, and then it'll be times 7, so that's going to be 700 minus 600, so that's the square of 100, works out evenly. Square root of 100 is 10 meters per second. And then the greatest height reached, which is the next part, this velocity will have to be equal to 0. So for it to be equal to 0, these two things will need to be equal to each other. So we're going to get 10,000 over x is equal to 600. So multiply across by x, divide across by 100, and divide across by 6, 100 over 6, 50 over 3 is equal to x. And then we'd have to take away 10, 30 over 3. So it will get 20 over 3 meters above the surface.